Hey everyone, so we're going to continue our discussion where we're solving log and exponential functions, and we're going to see some slightly more complicated examples here. So if we scroll down to the do now question, we had this scenario. There's a few different ways to go about doing it, but I think the easiest would be to get like bases. Now, I guess I should say 8 can't be rewritten as a power of 4, but both 4 and 8 can both be written as powers of 2. So I can write this as 2 squared, making sure that I keep the 2x plus 5 that was originally on it, and turn the 8 into 2 cubed. Again, making sure to keep the 3x that was originally on it. Multiply the exponents will end up being the same. From here, I could distribute. I get 4x plus 10 equals 9x. Subtract the 4 to both sides. And I get 10 equals 5x, x equals 2. So we could double check since they want us to verify. So 2 times 2 is 4. 3 times 2 is 6. So essentially what I have to do is plug into the calculator, see if 4 to the 9th equals 8 to the 6th. Right. Yeah, and I get the same number both times. All right. So now the question is, what if we can't get like bases? So we were able to get like bases in that scenario. But now, what if we can't? Oh. Sorry. So first thing that we want to do is get the base by itself. So this is what we have in this scenario here. We have 5x equals 7. So there's no other thing with this base. Then we're going to take the log of both sides. So we take, I guess we do move the 5 over, log base 5 of 7. So kind of remake it as a, as like this. So this is one way we can do it. And we could plug in the calculator. Log base 5 of 7 to get that x equals 1.209. That's the 1,000. There is a second way that we could do it, and this is for if you don't have a graphing calculator on hand or a calculator that can do different bases. So we can take log base 10 of both sides. And then remember, for the power rule, you take the x, put it in the front. So this becomes x log 5 equals log 7. Get rid of the log 5, or divide the log 5 to both sides. So we could also say that x equals log 7 divided by log 5. And this time when you plug it in, you'll end up getting the exact same number. So 2 methods to get to the same answer. I'm going to try to use the second way where we're just using logs or ln's and doing that for both sides, just because I'm not too sure how many people have graphing calculators at home. So scrolling down. We could verify this answer. This one would be tough to verify. Again, you'd have to use a calculator. So we would do 1.209. And when you plug this into the calculator, you end up getting 6.999302, which is essentially 7. So if we expanded this, our value of x to something past the thousandth, maybe we went to the millionth or something, then we would definitely get, much closer to 7. So that's pretty much the setup. Here's another example. So here we actually have, we can see right off the bat that we can do something before we should take the logs. We want to isolate this base. So we divide both sides by 6. So we get 2x plus 3 equals 5. Again, take the log of both sides. Move the exponent to the front. Divide both sides by log 2. We're left with x plus 3 on the left. And on the right is log 5 divided by log 2. Subtract 3. And we get x equals log 5 divided by log 2, which would net us the number negative 0.68, rounding to the nearest hundredth. Next part says verify. So what we would do, 0.68. And let's see, I do 6 times 2 to the negative 0.68 plus 3. I end up getting 29.9599, which is essentially 30. All right. All right, so here's another one. So here, if we have an e term instead of just some other number, we can solve this a little bit easier by, instead of using log, doing ln, but it ends up being the same setup. So I would subtract 8 to the other side, and I get 2e to the x equals 4. Divide both sides by 2. E to the x equals 2. Take the ln of both sides. Here, because we have, actually I'll just move the exponent to the front. Let me do this part first. All right, so here, if you recall, e was something around, I always end up forgetting it off the top of my head, 2.718, but ln of e is always equal to 1. So this basically drops out. So we're left with x equals ln of 2, which, plugging this into the calculator, get a number to the nearest 10, gets us 0.7. And again, we can verify. Plug this into the calculator. And we end up getting 12.028, which is essentially 12. So that's the weird thing about this, is that you're gonna, or that's the special thing about this, is that you're gonna need to make sure you have a calculator. Unlike the other ones where you could have done a lot of this in your head, this one you really can't. All right, so we don't need to do anything with the 3 to kind of get it by itself. So we're just gonna go straight to doing the log of both sides. Move the exponent into the front. Divide both sides by log 3. It's important not to go and do anything extra. Try not to say that log 15 divided by log 3 is log 5. That's not the case. The only time you can actually combine them into one term is if you're adding or subtracting log terms. We don't have that here, so just leave it the way it is, and you can plug that into your calculator. I'm going to keep it as this weird fraction for now. and then I'll just plug it all into the calculator at the very end. So we end up getting x equals log 15 divided by log 3 minus 1 over 2, which when we plug into the calculator, I apologize for how long this is going to take. We end up getting to the nearest hundredth, 0.73. Over here, we have the e term, so we're going to take ln of both sides. So this, the exponent goes in the front, so this becomes x ln of e equals ln of 43. Ln e is just 1, so that drops out. Plug in the calculator, ln of 43 is 3.76. All right, here's the next one. We have a term in front of the e, so we're going to want to divide both sides by the 150. Actually, we're going to want to keep this in fraction for now. Take the ln of both sides. Once you do enough practice examples, you'll start to kind of go straight to the point with some of these things. Drop the e. So another thing to think of is that every time we take the ln of e, then whatever our exponent on e, that's what gets left over. Divide both sides by 0.05, and we get ln of 34 divided by 15 divided by 0.05. Oops. Divided by 0.05. All right. For this one, add the 2 over to the other side, and we get 4x plus 2 equals 14. Take the log of both sides. X plus 2 log 4 equals log 14. Divide the log 4 to both sides. Get x plus 2 equals log 14 divided by log 4. Subtract 2 to the other side. We get x equals log 14 divided by log 4 minus 2, which when we put it all together, we end up getting that x equals negative 0.096. But since we're constantly rounding it to the hundredth, that turns the 9 into a 10, and it rounds to that. All right, we'll do a few more questions. So here, there's really nothing I can do, so I go straight to the log. Log 4 to negative x plus 2 equals log 18. X plus 2. Log 4 equals log 19. Divide both sides by log 4. Subtract negative 2 to both sides. I'm left with this. I'm going to divide both sides by negative 1, and what this is really going to do is flip the signs on the log term and the 2 term, which I can then just write it by flipping the 2 terms around. That way now we can see that the 2 becomes positive and the log terms become negative. So putting this into the calculator, I get 2 minus log of 19 divided by log 4, negative 0.12. All right, over here, take the ln of both sides. Remember, when we take the ln of an e term raised to some power, all that I'm left with is just the power. And then ln of 40 on the right. Subtract both sides by 3. Divide both sides by 2. And in the calculator, I plug in ln of 40 minus 3. Divide that all by 2. I get 0.34. All right. I think we'll end up doing 2 more questions, and then you'll just make sure to submit the rest when you can. Divide both sides by 8. So 36 divided by 8. The simplest fraction will end up being 9 halves. Take the log of 9 halves. Divide both sides by log 2. So we get log of 9 halves divided by log 2. Add 5 to both sides, and I'm left with x equals log 9 halves divided by log 2 plus 5. Plugging this into the calculator. I get x equals 7.17. And then this will be the last one. Divide both sides by 12. So 50 divided by 12 in lowest fraction form. Is 25/6. Take the ln of both sides. This ends up just leaving me with the 0.34t. And this will be 25/6. Divide both sides by 0.34. Okay, and then plugging all this in, we get 4.20. All right, and that's pretty much it. If you have any questions, feel free to let me know. Otherwise, good luck and have a great day.